Hello, welcome to a short video demonstrating the capabilities of the VectorBlox MXP processor. What I'd like to show you today is the capabilities of the VectorBlox MXP at accelerating some image and video filtering applications. We're going to use the ZedBoard here with a Xilinx Zinc device on it, as well as an Avnet HDMI I/O board. For a video source, we're using Western Digital TV box. It's outputting 1080p resolution at 60 frames per second. And we have a 1080p monitor here. So we're using high definition video, 1920 by 1080 pixels, 60 frames per second. First, let me show you that we're actually generating data on this board here. So we have calculations being run entirely on the FPGA and being demonstrated on the monitor. And we're showing a particle simulation where every particle is interacting with every other particle. For this, what we have to do is we have to integrate the forces involved. So for every particle, we have to calculate the distance to every other particle. And from that distance, we calculate a force. And then from the force, we calculate a change in velocity. And then from that, a change in position. So overall, the forces are repelling each other, keeping the balls separated as they move around the screen. Now it's being shown to run at 33 milliseconds per frame, or 30 frames per second. And if I was to switch over to the ARM processor, this is the ARM A9 running at 666 megahertz. It runs at 55 milliseconds per frame, or 18.5 frames per second. And you can see it's a little bit slower. If I go back to the VectorBlox MXP, it's a little bit smoother because it's running at 30 frames per second. So the overall speed up here is 1.6 times. The reason we get this speed up is through parallelism. We're using the FPGA fabric, and we have 16 parallel ALUs running at 100 megahertz each. Even though the ARM processor is running 6.7 times faster clock frequency, we're still 1.7 times faster because of the parallelism. Now in this demo, we can actually make the FPGA version much faster than we're showing here. For example, if we had a larger FPGA, instead of 16 parallel ALUs, we could have 32, 64, or even 128, and that would produce a significant speed up. Also, this is running at 100 megahertz on a lower end Zinc. On the higher end Zincs and on Vertex and Kintex, we expect a 200 megahertz clock speed, so a doubling of performance, on top of having extra parallelism. Furthermore, this vector version right now is being shown with a software divide operation because we don't have a hardware divide in there natively. However, we're developing a new version that will have a hardware divider, and this can be optionally included. The hardware divider will make this application run 4 times faster. Furthermore, we can go even faster than that. We can take the entire force equation and put that as a pipeline into the processor. And then the vector processor is going to be providing data to this pipeline. With that, we expect an overall speed up of over 40 times compared to this. And overall, we're getting into faster than Intel class performance then. But we'll leave those demonstrations for a future video. Instead, let's get back to the video filter application. So what I'm going to do is I'm going to start the video on the Western Digital TV box now. And what we're doing is we're running a face detection algorithm. And so you can see a green box is appearing whenever a face is detected on the screen. This is a standard Viola-Jones face detector that uses a HAR classifier system. The HAR filters determine where the face is, and the HAR filters are general, so they can be substituted or changed to detect cars or traffic signs or profiles and other types of objects. This is running at 8 frames per second. And if we were to switch to the ARM version, performance drops down to 2.6 frames per second, and so it's significantly more jerky. We go back up to the accelerated version, 8 frames per second, and a speed up of 3 times. So this is face detection. We can also do edge detection. This is standard Sobel edge detection filter. It's a 3x3 filter, run in the horizontal and vertical directions. And it's run on the full 1920 by 1080 resolution of the image. Normally this sort of thing would be done in hardware, but in software we're running this at 41 frames per second. If we switch this to just the ARM version, it runs at 5 frames per second. And if we switch back, then we see the overall speed up is about 7.5 times. So you can get real-time filtering purely in software by using a general accelerator like the VectorBlox MXP. Lastly, let me just show you Mandelbrot calculation being done on the MXP, another parallel application. The frame is being generated in 0.7 seconds. And if we switch to the ARM version, it takes 4.3 seconds. So the overall speed up is about 6 times. Again, the MXP is capable of higher speeds if we dedicate more FPGA logic resources to it, or if we increase the clock speed, or if we add custom instructions to do things like divide, or if we add custom pipelines to do more general equations. So I hope that gives you an idea of the performance potential of the MXP. It can make the Zinc platform much faster and completely software programmable. Thank you.